So, welcome ladies and gentlemen. We are looking at what I did on Friday, and we are looking at Balancing Chemical Equations 1 in your packet, page 3. So what we will do is we will list all of the atoms that exist. We will start with polyatomics, all atoms, and then hydrogens and oxygens. This is the best suggestion of the order for which you will do these. So as I look through this equation, I see that this does not possess any polyatomics. So then I will start then with aluminum and sulfur. So I'm pulling apart all of the atoms if there's no polyatomics. I'm going to put them right there underneath the arrow as to show as the divider. On the left side of the equation, I have one aluminum and one sulfur. So I'm referring to this area right here. There's one of these, one aluminum and one sulfur on this side. On this side, I have 2 aluminums and 3 sulfurs, so I will put a 2 on the right side of aluminum and a 3 on the right side of sulfur to represent this 2 and this 3. Now I'm going to add the units, meaning that in every situation I can add either Al and S on this side or an Al2S3. I can't add a piece of each unit, I have to add the entire unit. I see that I have 1 Al and 2 Al, so I need to add an Al on this side, so I will add it. So there now I have 1, 2. I have 1, 2 Als. So then this changes to a 2, and I've got 1 and 3 sulfur, so I need to add 3. So there's 2 and there's 3, so now this goes to 3. Now you can see that we have 2, 2, 3, 3. So then I will go and write my coefficients. Coefficients are the numbers that go in front, so I'm looking for the number here, here, and here. So here I have a total of 2 aluminums, so I'll write a 2. Here I have a total of 3 sulfurs, so I'll write a 3. And here I have only 1 Al2S3. I didn't have to add any, so I will write 1. Technically, actually, we will not write 1. What I should say is that that is a 1. We just don't write the 1s. We leave it blank, meaning that it is 1. Next problem. Do you see any polyatomics? There are none. Remember, a polyatomic is a unit, that group of atoms acting as a positive or a negative. So then we're going to do zinc and oxygen. Why oxygen second? Because if oxygen is present, we're going to do it very last. As I look here, I see that I have 1 zinc and 2 oxygens on the left, 1 zinc and 1 oxygen on the right. So my zincs are balanced. Now I need to balance my oxygens. I have 2 and I have 1. So I'm going to go over here to get 2 oxygens. To do that, to get another oxygen, I have to add the whole thing. I have to add the unit. So ZNO must be added. That makes my zinc go to 2, my oxygens go to 2. Okay, so now my oxygens look good down here. There's 2 and 2, but now my zincs just got messed up, so I got to fix my seesaw, my teeter-totter. I need to add a zinc over here to get it to 2. Now I have 2. Now I have 2. So this will go to 2. So I have 2 and 2 and 2 and 2. So now that it's balanced, I'm going to add. I have 2 zincs. Right here I have 2 zincs, so I'll put a 2 there. And I have 1 oxygen, so no other oxygen, so added just 1, so I leave it blank, and then 2 ZNOs. So I would read this for an answer as 2, 1, 2. Example 3. There are no polyatomics, but I do have Mg and Cl. On the left, I have 1 GM and 2 Cls. On the right, I have 1 Mg and 2 Cls. So notice that it's 1, 1, 2, 2. So all of these numbers, going across, 1, 1, 2, 2 are balanced. Therefore, you need to tell me that it's balanced. I want to make sure that you need to tell me that it's balanced by writing balanced or balance or something to show me that you know, that I know you looked at it, that you just didn't skip it. All right, this next one, I do not see any polyatomics, number 4. So I will list aluminum and oxygen. I would do oxygen last because that's usually the best way. On the left, I have 1 aluminum and 2 oxygens. On the right, I have 2 aluminums and 3 oxygens. So I'm going to work with aluminums first. I need to get 2, so I add an Al over here. So now that I have 2 aluminums on that side. Now, oxygen has 2 and 3. I got to get them both to a 6. So when you have a 2 and 3, you always get them to the lowest number they have in common. The lowest number they both have in common is 6. So to get 6 aluminums on the right-hand side, I add another piece. Remember, I have to add it as Al2O3. So now you notice that I have 6 oxygens, 3 plus 3. So this goes to 6. But that also made me go to 4 aluminums. So this becomes a 4. All right, fix my oxygen still. Don't worry, I know we messed up the aluminums. We'll come back to them. We're still working with oxygen. I need 6 on the left. So that's 4. 2 plus 2 is 4. And now that's 6. So now I have 6 oxygens. 2, 4, 6. Now I have 6 and 6 for oxygen. Sorry. I have 6 and 6 for oxygen right here. But my aluminums got messed up. Well, that's okay. I can keep going back and forth. I have 2 and 4. I need 4. So I add, there's my 3rd. There's my 4th. Now I have 4. So now you can see our numbers in our work, our balance, 4, 4, 6, 6. Now I can do my coefficients. Remember, coefficients are the numbers in front of the balanced equation, or the compounds and elements. So there's a 4 here, a 3 here, and a 2 there. All right, so that's the first examples I did. Now we're going to switch to page 5. So if you could please switch to page 5 in your packet. And we're going to start with number 1. Same set of questions. Are there any polyatomics? There sure are. I see NO3 on both sides. I also see a Cu on both sides and an Ag on both sides. Okay? See NO3 is on both sides. When I look at the count, I have 1 on the left of NO3, 1 Cu and 1 Ag. I have 2 NO3s, 1 Cu, 1 Ag. So those numbers come from counting the pieces. Now I'm going to start with NO3. I have 1 and 2. I need 2 NO3s. I have to add the whole unit, so I have to add an AgNO3. I can't just add the NO3. That makes this go to 2, but it also makes my Ag go to 2. So now I have 2 and 2. NO3 looks good. NO3 looks good. Cu looks good, but Ag is 2 and 1. To get it to 2, I put an Ag here. That makes my Ag go to 2. And so now I have 2, 2, 1, 1, 2, 2. So now I'm just going to do my coefficients. There's only 1 copper, so I leave it blank. There's 2 AgNO3s, only 1 copper nitrate, so I leave it as a blank. And then there's 2 Ags. So this would be read as 1, 2, 1, 2. Remember, we just don't write the ones. We're going to skip number 2 for now and go to number 3. All right, again, we're going to look for polyatomics. I see 1. I see SO4. I see Al. I see Br, and I see H. I would do H and O's that are not part of the polyatomic last. I would do H's and O's that are not part of the polyatomics last. So as my list here, I have 1 SO4, 1 aluminum, 3 bromines, 2 hydrogens. Over here I have 3 sulfates, 2 aluminums, 1 bromine, and 1 hydrogen. So we're going to fix the SO4s. By doing that, we need 3 of them, so we're going to add 1 at a time. Now we have 2 of them over here. Now we have 3 of them. So this goes to 3, but my H goes to, notice here, on our H's, we have 2, 4, 6, so this H goes down to 6, or goes, up to 6. All right, now that SO4 is balanced, I'm going to deal with my aluminums. To fix my aluminums, I have to add an AlBr3. Can't just add the Al, must add all of it, so this goes to 2, and bromine goes to 6. So if you look here, you should see that you have 2 Als and 3 plus 3, so 6 Brs. All right, so now I have sulfates, SO4s 3 and 3, aluminums 2 and 2, Brs 6 and 1, so I got to get 6. So I add, now I have 2, now I have 3, now I have 4, now I have 5, and now I have 6. So now I have 6 Brs, but as I did that, and if you would count, you would see that you have 1, 2, 3, 4, 5, 6 hydrogens also, which is awesome because now we have 3, 3, 2, 2, 6, 6, and 6, 6. So now our work is balanced. Now we're going to add our coefficients. 3 here because there's 3 of them. Okay, 2 AlBr3s because there's a total of 2 of them. And then 6 HBRs because there's 6 of them. And then the Al2 parentheses SO4 parentheses 3 would stay a blank or a 1. All right, example number 4. All right, on your paper, your example number 4 has it written as H2O. Anytime you have an H2O, I would encourage you to scratch it out and write it as HOH, because more than likely it's going to help be easier to balance that way. So as I look at this problem, I have PO4 and I have OH. Those are 2 polyatomics, which makes it easier to balance often. I also have ALs and H's left when I get rid of or account for my PO4 and my OH. So my PO4 on the left is 1, my OH is 3, my AL is 1, and my H is 3. On the right, I have 1 PO4, 1 OH, 1 AL, and 1 H. Again, I would cross off H2O over here, and I would write it as HOH. If you don't cross it off, you sometimes will go back and look at H2O and think you have 2 H's when you really have 1 H and 1 OH. So cross it off so you don't focus on it. My PO4s look great. They are balanced. My OHs are not. I have 3 OHs on this side and 1 OH on that side. So I'm going to add an HOH. That gets me 2. Another HOH gets me 3. So this becomes 3. And my hydrogen then becomes 3. Remember why? Because we now have 1, 2, 3. So we have a 1, 1, 3, 3, 1, 1. It's balanced. So now I just have to worry about putting my numbers in front. There's only 1 AlOH3, so I leave it. H3PO4, 1 of them, so I leave it. AlPO4, 1, so I leave it. And then I have 3 HOHs, so I put a 3 in front. All right, that concludes my notes. Please use this to help you finish what was assigned to you today. Thank you.